Hello and welcome to the fifth lesson in Spiral 4, Graphing Linear Relations. So what do I want you to be able to do today? You can demonstrate how to graph linear relations when you're provided with a variety of information. So we're going to give you some different information. We've seen some of this already in earlier spirals, so this is a bit of review. So create a table of values comparing the frame number to the number of tiles in the frame, graph the data, find the relationship. Okay, so we got our first three frames here. I'm going to move down here. I'm going to leave a space for argument's sake. So 1, 2, 3. So for the first frame, there was one tile. Then there was 5 tiles. Then there was, what do we got here? 1, 2, 3, 4, 5, 6, 7, 8, 9 tiles. Okay, we have a variety of tools at our disposal. We can draw the next picture if we want, the fourth one. Then what we'll find is, if we go through and do the process, it's going to be 13 tiles. All right. And the reason is, if you look at the base structure, all right, so if I draw that base structure, guess what? We're just adding on to each of the wings. All right. So, describe the trend. Well, we don't really need to graph it. Okay. It's there if we need to. But we know that the pattern here is we're going up by 4 each time, and we're going up by 1 each time. So the trend, because it's the same each time, what does that mean? It means we have a linear relationship or, no, we won't go, I was going to use the word correlation, but we don't use that. So we have a linear relationship, all right? You can draw the graph if you want. That's what the question asks, or it says graph the data. See if you can find the relationship in the data, but we're at a point where we don't need to. All right, we can just look at this table of values and make the decision. Now, some people may have to if it comes to EQA or a test. Go ahead and graph it. There's nothing wrong with that. Can you find a way to determine the number of tiles just knowing the frame number? This is a fancy word for what is the equation or model. So here we go, coming up with an equation. So I left space in the table of values because we want to find the missing value. So if we go 4, 3, 2, 1, the next value will be a 0. And the other one, we're going down by 4s. 13, 9, 5. 1 take away 4 is -3. And you think back, what does this mean? All right, what does this mean? Last lesson in Spiral 3. So if we have 0, -3, it tells us a couple of things. First thing, this is a partial variation. Okay, it's not 0, 0, so we have a partial variation. What's the second thing this tells us? This tells us that our starting point, initial value, depending on what you want to call it, is equal to -3. So our initial value is -3. So that's what that tells us. 0, -3 tells us two pieces of information. Why is it important for partial variation? Well, we know that the equation for a partial variation is our first differences times x plus our initial value. Well, we know the initial value is -3. And if you look up, what is our first differences? Well, it's a unit rate. It goes up 4 for each one. So it would be 4x minus 3. There we go. That will tell us any frame number we want. We can solve it from that. And you can get that equation from the picture as well. All right, here's your initial value of 1. And we're adding 1, 2, 3, 4 squares every time. Here's your initial value. We added 1, 2, 3, 4, 5, 6, 7, 8. So we've added twice as many. We're adding 4 each time. So that's where that 4 comes from. All right. If you have any questions, stop the video and ask the teacher for help or clarification. What about this? How are the non-right angles of a triangle related? All right. So basically what's happening, this is corner X. All right. So for the first one, this is 10 degrees. If that one's 90, then the other one has to be 80. All right, if it becomes 20, that's all that they're doing here. So what happens if this becomes 20? Well, this one becomes 60. If it becomes 30, oops, you're probably saying, what kind of math is he pulling off here? No, sorry, 70. 30 would be a 60. Then you'd have a 40, 50, 50, 40. So we're just adding, the two angles have to add up to 90 each time. All right, so we're just finding the missing angles. There we go. So how are they related? So using words, write a rule that shows that you need to do with what you need to do with x to get y. Again, we're past this. We've already done a lot of work in the earlier spirals. So let's skip some steps here. Let's write the equation. So I'm going to use this space here, okay, this space here to do some of the rough work if necessary. So let's talk about this. What type of relationship do we have? So if we look, what's happening each time here? We're subtracting 10. All right, it's going down by 10. What about the other side? The other side is going up by 10 each time. All right, so that means that we have, first of all, a linear relationship. We have a linear relationship in this case, and now we can figure out what our first differences are. All right, our first differences. So for every 10 we go down, this side goes up by 10. So negative 10 divided by 10 is equal to negative 1. All right, negative 1 is our first difference. Can we find our initial value? Okay, because if we're going to find an equation, that's what it wants us to do down here. It wants us to find an equation. Well, we know the equation is first differences times x plus the initial value. Well, we just found our first differences, so that one's done. Can we find the initial value? When I go back to the t-chart, we can just follow the pattern in reverse. So if we look at the x column here, all right, 80, 70, 60, 50, 40, 30, 20, 10. So the next one would be a 0. On the other side, 10, 20, 30, 40. It's going up by 10s, so it would be a 90. There we go. It's a partial variation. All right, that's what that tells us. Partial variation. And our initial value is 90. All right, so now we know that. We now know the equation to this model. So y equals negative 1x. You don't really have to write the 1. And the other will be plus 90. All right, so there's the equation or the relationship between the angles inside a triangle. If the bottom angle x in a right triangle is 35, what's the top angle? Well, you can find this using just adding and subtracting angles, but let's just check. So we know. All right, let's check to make sure our model works. 180 degrees in a triangle. We have one angle at 90. They're saying one of the angles is 35. All right, so we go through, we do our math. We get the 180 minus the 90 minus 35. We know the answer has got to be 55 degrees. So our equation, is it going to work? So if we know that the one angle is 35 degrees, oops, I'm going to write it out the way you're supposed to. Okay, I'm going to try to write it out the way you're supposed to. We know that one angle is 35. So we can enter this into our script calculator or your iPad calculator or your phone. Negative 1 times 35 is negative 35 plus 90 equals 55. So that means our equation works. We now have a working or functioning equation that will allow us to find that missing angle. So at that point, that's where we're going to leave it. If you have any questions with this, you can see that we have a whole bunch of tools at our disposal now. You can use your T-charts. You can graph it. I never graph it because there is so much information from the T-chart, but if you prefer graphing, you're more than welcome to go ahead and do it that way. So if you have any questions, make sure you ask your teacher for clarification. We'll see you in the next video.